All right, let's take a look at this next problem. The directions are the same as the previous, that we want to um, find the maximum value and the minimum value of the output of this function, and that's going to be pretty easy. But sometimes in finding the location of where that occurs, sometimes students have a little bit of difficulty with that. Um, ah. So here we're not changing the center line. We're not lifting the graph up or pushing it down, so it has the same center line. The amplitude is 1. So if you're on this center line, if you go up 1 unit, you'll be at the maximum. 0 plus 1 is 1. If you go down 1 unit, 0 minus 1, you'll be at the min. So those are fairly easy to identify. Now, um, if they weren't restricting us on 0 to 2 pi, this max and min occurs an infinite number of times because the domain is a set of all real numbers, and this cycle just repeats itself forever to the left and to the right. But on 0 to 2 pi, let's figure out where it hits its maximum values and where it hits its minimum values. We know that it may not be the same as the parent function, because we've changed both the period, because there's a coefficient in front of x. Now this is in factored form, and sometimes you'll see them have brackets here to indicate that you're taking the cosine of that entire product. But we're changing both the period, and we've got a shift to the right, so it's going to definitely affect where it intersects the center line and where the locations of these max and mins. But we know that if we replaced this expression, pi times x minus 2, if you replace that with 0, we know that at 0 you're going to be at your maximum value. So to solve this equation for 0 is pretty easy. 2 minus 2 is 0, so x equals 2. All right. Now, we also know that the distances between the maximum values or between the next minimum values is the length of the cycle, is the period. So in this case, the period is 2 pi divided by pi, because pi is the coefficient in front of x. So this period is 2, and so the next maximum occurs two units away from this, which 2 plus 2 is 4. And then the next maximum that appears after that is going to be at 6. Now, if you don't believe me that I can just come in and add a cycle to that, you can come in again with this expression, pi times x minus 2, and replace it with where the next location of the max is, which is at 2 pi. And you can say that x minus 2 is equal to 2. Well, 4 minus 2 is equal to, so you have a 4 there. So, and the only reason I added another 2 is on 2 times pi is about 6.28. So there's 3 locations, there's 3 times over this interval that if you plug in these 3 different values, you'll have a maximum output from this function of 1. All right, so let's find the locations of when it's negative 1. If we replace this pi times x minus 2, if we replace it with pi, then we know that we're at a minimum value. The pi's cancel, and x minus 2 equals 1. X is equal to 3. So at x equals 3, we know that we're at a minimum value. If you plug in 3 into this, 3 minus 2 is 1, and the cosine of pi is negative 1, and that's a minimum value. If we're the next location of this is a cycle away, if our cycle, if the length of our period is 2, then the next time that occurs is at 5. And then the next time it occurs after that is at 7. But 7 is bigger than 2 pi, because 2 pi is about 6.28. So we were going forward 2 units. What if we went backwards 2 units? 3 minus 2 is 1, and 1 is bigger than 0. So again, we have 3 locations, but because this had a shift to the right, we had to, this initial point move forward to the right, and we had a minimum value that snuck in to the left of that on that interval from 0 to 2 pi. So we have our answers here. We have a maximum of y equals 1, and that maximum occurs at 3 different spaces between 0 and 2 pi. It has a minimum value of -1 that occurs at 3 different locations on the interval from 0 to 2 pi. All right, so I hope that helps, and I'll talk to you later.